go from kind of broad to increasingly technical. After this morning, this one's particularly strikes my sensitivity. I was delighted to see Brian fall on his sword on the topic of battery management systems, so I thought I'd return the favor. EVTV is on at least two fronts, developing a BMS. How can that be? Would you believe in the state of California you cannot sell an electric vehicle without a BMS? Yeah. Do you know how they define a BMS?
Voltmeter.
They don't at all. They know you need one, and they're not sure what it is, but it should be the law of the land that you should have one. Excuse me? Well, actually, the state requires it, but yes, the insurance companies want you to have one too, and some car shows insist that you have one. And I've watched this with some amusement because I never see a definition of what one is. The best they'll do is that it monitors voltage and temperature, and it never really says what. So people are going to have a battery management system, and from this point, I get to define what one is from scratch. Actually, Brian, our no BMS or living BMS-free, one day at a time position came from a search for a BMS, followed by me having some crude attempts at designing one, and which led to several fires in the laboratory while I'm standing there. And my abject horror of them go to one thing, and that is normally when you're charging your car, you're not there. You're in bed. And sometimes the car is underneath you in your garage in your house. And we actually kept records, photographs, and interviews on 16 vehicle fires, some of which have led to legislation in various countries. For example, Norway, you cannot import a converted car at all now. It has to be produced by an OEM because of the Princess of Scandinavia fire of a Nissan Qashqai that took out a ferry and sent it back to the port of origin while it was charging on the boat using one of Dr. Dennis Werfer's BMSs to operate a perfectly serviceable Brusa charger that would have terminated the charge on its own. But it was under CAN bus direction and a battery management system, and it almost burned a boat up with people on it. Fires at sea are somewhat more serious than they are in your garage. Don't ask me how I know, but I did survive 3 on the USS Midway, and some did not. And to this day, I will not allow a Mr. Coffee in my house because 2 of the 3 were caused by Mr. Coffee coffee pots on the USS Midway, believe it or not. One of them was somewhat more dramatic, a KA-6 tanker that hit the round down and put the whole flight deck on fire. But fires at sea can be very serious. Fires in warehouses, as Neil Young had with his Lincoln, not only took out the car, but took out a warehouse. And Neil had to pay $345,000 for the warehouse. Because of the insurance issues, it can be very difficult to get the principals involved to tell you the truth about what happened because they want to be paid by the insurance company. And it kind of depends on what happened. And so it's kind of an interesting thing, just chasing fires in electric vehicles. They almost never happen with people driving the car. They usually occur at 3 o'clock in the morning, which is the end of charge period, not the beginning. And it usually involves an overcharge of batteries. Last year at the conversion convention, we actually demonstrated the overcharge of a CA series, I think, cell to the point of fire. And it took quite a bit, particularly the light force cells are considerably better with this than the lithium manganese, and they're considerably better than the lithium cobalt cells. But if you overcharge them hard enough, they will go into a thermal runaway. And when they do, at a temperature, the cathode gives off free oxygen. And the cobalt oxide cells give off oxygen very readily, something on the order, I'm gonna make these numbers up, but as you know, I can make the shit up to be closer to most of the guys who design it. About 150, 160 degrees centigrade. Lithium manganese is up over 200, 220, something like that. The phosphate oxygen bond in the lithium cathode, lithium iron phosphate cell is particularly strong. And you have to be up over 350 degrees centigrade. When it does give up free oxygen, you can't put the fire out. Actually, the best thing is a solid stream of water. And last year I bought a fire extinguisher from John Metric that was particularly high tech. It's a can of water. I never did get that nozzle to charge it with the air to pressurize it. But a solid stream will lower the temperature, and it's your only hope of putting out lithium iron phosphate fire. If you've ever seen the aftermath of some of these fires, there's no glass in the car, there's no rubber on the car, and usually the transmission is about this tall and oddly shaped, kind of like a puddle. They are intensely hot fires, typically over 5,000 degrees Fahrenheit. And once it starts feeding itself its own oxygen, they're peculiarly difficult to put out. You mostly stand around and watch until there's nothing left to burn. The problem, of course, is that they're normally an end of charge phenomenon. That happens at 3 o'clock in the morning and there's nobody there. As you know, we like to keep our cells, and we kind of depend on the fact that they actually don't drift in state of charge. But we found 36 different ways, very innocently, and usually accidentally, to take little minute bits of charge out of them, and at we call parasitic loads, and throw them out of balance. And the math on this is frightening. It is literally nanoamps in some cases, but it happens every second for a minute, every minute for an hour, every hour for a day, every day for a week, every week for a month. And after 3 or 4 months, you'd be surprised how much of this accumulates. It's very cumulative. Then if you get in the car and go drive it with 14 of your cells 10 amp hours lower than the other ones, surprise, surprise, all you did was lose the 14 cells, and that's expensive. So my approach on battery management systems is first do no harm. And what we've advocated is the JLD 404, an inexpensive, innocuous, cheap, and not very accurate meter. But it lets you measure voltage, current, and amp hours, and there are ways to kind of tell what's going on from that little bit of information. As you get used to your car, it gets to be a little less important. I can glance the voltage now on most of my vehicles that I'm familiar with and have been riding, and tell pretty close to what I've got going. The new guys with the new builds want to see every voltage and every temperature of every cell completely. And they want to see that really bad for about 3 days. It's a lot of information. You kind of glaze over. And if you focus on it really carefully at about 40 miles an hour, we get to buy your parts back. Which brings up another topic. We view automotive operation and automotive maintenance as 2 separate things. I don't need to know all that stuff when I'm driving a car. I need to know I got a problem or that I don't have a problem. And I'd like to know where I'm at gas gauge wise. Now when I do have a problem, let's take it to the shop. I can wheel up tons of test equipment to figure out which cell where. And so that today we're going to talk about 2 approaches. We've got 2 programs going, and And one of them addresses the JLD 404, whose coolant counter is not real accurate. Actually, it's not bad, it's not very facile. If you're measuring current accurately at 300 amps, you probably aren't at 6 amps. And I can also set it up where you're measuring quite accurately at 6 amps, but then you're not at 300 amps. As we go into AC systems, which have, you go out and then with regen come in at 2 different levels, this starts to get to be problematical. We also can't really do much with the JLD 404 when we switch 2 outputs and we can read big red letters. And one of the reasons we offer it, and I like it, is they're big. And for 59-year-old eyes, that's easier to read than little LCD things. And so it's purely a functional display. I'd like to introduce now, I said we're kind of getting into product development worldwide. Mark Weissman and I come up with a lot of good ideas, and normally Colin Kidder and Paulo Alemeida then mail us out on when we don't work. And it's kind of interesting. We're working toward sort of an international virtual development group or something. And it works surprisingly well. Paulo and Celso, kind of on their own, have developed a JLD 404 replacement. They call it the JLD 505. Would you all please welcome Celso, Menaia, and Paulo Alemeida, the Menaia of Lisboa. And this is kind of interesting. It's the oldest engineering college in Europe. It started in 1852, and it was more industrial then, but it's now a full university, and they're both there. And tell us what we've got going with the JLD 505.
Thank you, Jack. Okay, my name is Paulo Alemeida, Celso, like Jack has presented. Before we would like to start presenting here our slideshow, I would like the smart team to stand up, please. Everyone that has worked so far on the smart field. And I would like everyone to give a big warm applause to these guys. They have been working every night, last night up to 3 o'clock in the morning on the car. We will have it tomorrow at the race, so. Good on that. Celso start the introduction.
Okay. Usually, what we need to know on our battery pack is the state of charge. And the old days, state of charge would be determined by a voltmeter, because lead-acid batteries have a discharge profile that, just like this, it's very easy to know the charge of the battery by this voltage. Lithium iron phosphates are quite different. They have a very linear discharge curve, so it's more difficult to see state of charge by voltage. It can be done, but it's very hard. So, up to now, check, as for cell, is JLD 404. It measures curves going in, coming out, and we more or less can see how many amps come in, come out, and estimate the state of charge with this meter. One problem, it has no data output, so if you'd like to log a trip, a charge, a discharge, get some more data, know where you're at, it's more difficult, because just like Jack said, it's okay, but just an inputs and outputs, and no data out.
Cheesy display.
Yeah, cheesy display.
Yeah. So, before we start talking about the JLD 505, just a quick question here. For those who are working on older cars, you've certainly noticed that you are not having the problem to know all what's the ABS system, what's the traction control system, JFU, for everyone who's doing a new car now, ESP, ECU. There are all these abbreviations in the cars, and for me at least, I like to know what they mean. And it's easier for me to understand or to remember them if I know what when it comes to the JLD, I tried to look online, but I can't find what JLD means. So
Jack's little digital meter.
no, oh, that's good. That's good. I actually had Jack loves donuts. I think I can go with Jack's little meter. That'll be fine also. So let's talk a little bit about the design of the JLD 505. I talked to many of you already during EVCON, and there are some of you already developing some boards to monitor temperature, to BMS in the case of Ed Clausen. And let's talk a little bit about what's the best approach when you are doing something like that. I promise I will be not too technical on this. So first thing you need to find out is what you want to protect on the system. So if you are designing your board, you need to decide which component we want to protect. So in our case, it should be the microcontroller, because it's the if we burn the microcontroller due to high voltage or some interference or so, the system will stop running. So from what do we need to protect the microcontroller? For example, from the power supply, we have the 12 volts in the car system that will be converted to 5 on the controller. We should always have there an isolated power supply making this conversion. So that's protected with our ninja little guy there. So what else? In our case, we have an USB connection to the microcontroller. It will be a cable that will come from a laptop, from something, to our board. Once again, we will use an USB isolation chip there to protect our microcontroller. So there we go again. Bluetooth. We will have Bluetooth on our board. Once again, we will isolate it. Does everyone agree on this?
Entirely. That's my isolation from the wireless.
Yeah, you don't need it, so let's put our Bluetooth inside the car. It's a wireless protocol, so there are no wires. So that one is one that doesn't need to be isolated. So what else do we have on our board? Canvas, of course. Once again, let's isolate that. On our boards, we will also feature two isolated digital inputs. So you can have, for example, a 12-volt button to reset the amp hour counter or something like that. Two isolated digital outputs to drive, for example, some gauges like as Boston has done on his BMW, things like that. And of course, the isolated shunt and back voltage interface. So this gives you a global idea of where we and what we need to do on that board. So we did several prototypes of this. This was prototype number 1. It only had the interface to the shunt and back voltage. You can see clearly here on the PCB the isolation barrier, isolated power supply, and the communication isolation to the shunt interface. Our microcontroller, on this version we don't have the isolation on the USB yet, but we will have it in the final version. The version we are currently testing, and some of you have seen in a video that we made a couple of weeks ago, is the version 2. It's a little dark. I don't know if you can see anything, but this has the same interface to the shunt, microcontroller with the Bluetooth on the same area, and once again isolated power supply and CAN and bus. So this is the one we have. We actually have it here assembled, so anyone that wants to take a look at this is free to do it. Specs on what the final version will have. It will have, this is important, the power supply is a wide range power supply that can have voltage inputs from 9 to 18 volts. Usually when we say that the car is a 12-volt system, that's not entirely correct. Most of the cars are running at 13.5, 13.8, and there are some power converters that won't take that higher voltage in the input. Then we will have maximum battery voltage of 500 volts. That's the maximum we can measure in terms of pack size. Shunt interface with a fixed resolution of 2.5 microvolts. That means that, for example, on a 500 amp shunt, we will have a resolution of 17 milliamps. That means it's like almost 5 5 times better resolution than we get on a JLD for two digital inputs, like I said before, two digital outputs that can do PWM, one PAN channel, USB, Bluetooth, and it will be entirely compatible with the Arduino IDE, like the Jeffrey we have done before. Enclosure-wise, we selected for the final version that I'm working currently on. This one is a full waterproof enclosure that we will design the PCB directly to the connector and will be a fully closed and fully watertight system. So, really quick, any questions? That was the presentation about the JLD. Okay, you can start.
What shunt millivolts did you select for?
You can
all the Japanese or all the Chinese ones use 75. The Americans do.
You can use any shunt up to 3 volts at voltage on the shunt.
How much is it?
Depends on your shunt.
Okay, so if you have
You can, if you want a 10,000 volt 75 milliamp shunt, your only limitation is the resolution. This is a fixed value. 2.5 microvolts is a fixed value. Depending on your shunt, you will have the actual resolution in amps. So, yeah.
The shunt question comes up quite a bit. This is just kind of an Ohm's law function. It is simply a very low value of resistance, and they give it to you kind of rated at, for example, 75 millivolts is 750 amps. I can go in with a 50 millivolt shunt, but that full scale would then be 500 amps. And so you can kind of play around with this. It's simply an Ohm's law function. Did I say that backwards? Yes, a 50 millivolt shunt that is rated at 500 amps at 75 millivolts would show 750 amps. But this is programmable. We can make it anything you want. And what he's saying is the max is 3 volts, which is a preposterously high amount. You will never do that in an actual shunt because it heats if it's that high a resistance. You want low resistances and a low amount. But you'll certainly be able to have resolution at 50 millivolts or 75 millivolts.
No problem at all.
So if you put a 20 amp shunt at 75 millivolts, that you're really reading the voltage. And at 75 millivolts, you're going to put up on the screen or read the value 20 amps. If you replace the shunt with a 1000 amp 75 millivolt, at 75 millivolts, that's 1000 amps. And there's a whole lot of different, not only sizes, but qualities of shunts available to purchase.
Is this going to use the same send-down part that
Not at all.
No, this is the interface with the shunt is based on the Texas Instrument ENIA 226. Is the last that we are trying.
So you did try the 226?
Yeah,
I like
the
that.
226.
We started with the 220, and it's I found the 226 seemed to be
It's a little better.
marginally.
Another question, there's no display on here, obviously. It has Bluetooth and has USB. Is that the intent, is we're going to be going forward and have another display of some sort that we use?
We can connect this to the JFQ, for example, over CAN, and have the web page have on the browser, the page for the interface with it. You can have an application on a smartphone, on a laptop. The idea was to go exactly in the opposite direction, because with display, you already have the 404s.
I'm kind of agnostic on displays. It's not that I'm inattentive, but to some degree it's done. There's Android has Torque, and some of these others have others. We're kind of doing interfaces, USB, CAN, wireless. We can do wireless to an Apple iPhone. I could write an application for the iPhone, but so could many of you. If you're looking for an opportunity.
Chinese are already providing us lots of OBD2 Bluetooth bridges.
Exactly. They're $20 on eBay to, but you know, we've got 3 basic interfaces there: Bluetooth, USB, and CAN. And I mean, if nothing comes up, we'll do a display. but there's kind of a lot to pick from, a lot of other work out there. It's very easy to configure Android's torque to do a lot of things by CAN. It's quite flexible.
So with the JLD 404, one thing I ran into, that Jack had pointed out on the data sheet for me, was that the resolution is not the same in either direction, or rather the range.
The range
not
is not the same
in either direction.
On this it is.
It's the same range and resolution in both directions.
Bidirectional, exactly the same in both directions. There.
When you're, does the USB put out, do you get amp hours?
I forgot to put it on the slide. At the moment, we are streaming out the USB port, voltage, amps, amp hours, watts, and watt hours. In a continuous stream like we had on the solar like that. But once
And
again, it's
probably
programmable.
some way to configure it, like the JLD 404. One of the things is you can configure it to trip on
Yeah.
amp hours or voltage or
Time.
watt hours or
Whatever.
whatever to like switch a relay or something to turn off your charger or
What's the
do.
cost gonna be? Cost or availability? Maybe too early for cost.
We think we can bring this in somewhere under $3,600.
It will be the most expensive online you can find for sure.
If you find a higher price anywhere on the internet, we will match it.
$4,000.
No, I see this as kind of a replacement for the JLD 404. We haven't done the bomb PC.
We have the bomb for the prototype 2. I'm working on the prototype 3. But should be the first prototype 3 should be, I should have it assembled in 3 to 4 weeks. So after
I
that,
think we have the highest price there is available online for JLD 404, and I see this in the same price range.
Okay, in the back.
Yeah, a couple of questions. What's the absolute precision? So in percentage terms, you know, is it possible to 1% or 0.01%?
That depends on the once again on the shunt that you will use.
Essentially 22,000 telephone poles per hour.
What the ENIA 226 has the minimum resolution. It has a 12-bit ADC in it, and the minimum resolution is 2.5 microvolts. If you use a shunt with 75 millivolts, then
He wants me to do the math for
You
him.
understand? No. You understand the difference between resolution and precision, though, right? You can get a multimeter that's got 5 digits, but it's still only plus or minus 1%.
yeah,
And the resolution doesn't mean shit. It's how precise is the measurement.
It's gonna be as precise as your shunt is. Actually.
yeah.
No, I don't.
On the shunt
Do you
really.
have any calibration on board for your analog to digital conversion? How do you actually know? What is the quality of your voltage reference for your?
Okay.
Yeah.
On the ENIA, I think it's 1%.
Because 1%.
I need to check the data sheet on that, but I'm pretty sure on the 220 it was 1%. I think this is a little better.
And the same for the voltage.
Yeah, they use the same ADC converter.
Because 1%, I mean, that's usually 5 volts, 500 volts. It's pretty low precision.
I don't think the JLD 404 is better than
No,
the
it
The idea here is not to have a high precision interfacing shunt measurement tool. For that we have what Ed Clausen is working on with the Sindai. This is just to take what the JLD 404 can do and have more interfacing it with more devices. For example, if you're using your petrol car, what's the precision on your fuel gauge?
And my other question is there any parasitic draw of the battery?
No.
No.
We have
Sure, you're using some 12 volt,
but we are taking it off the whole pack, not
it's not a parasitic load off a particular part of the pack.
Yeah, the input is one.
Is it like 10 mega?
We have let power packs down very low with the JLD 404. With enough months and the maintenance switch on. You gotta park your car for 6 months, have a switch that breaks the back and cuts everything. Because that's got us a couple of times.
This now has an input impedance of 6 megohms, I'm sure.
Okay.
So it's high enough to ensure a low parasitic load.
Did this, share the same shunt? So
Yeah.
You already have a 404 in,
Yeah.
and you want to add this, and you could look.
Sure.
The shunt interface is a voltage measurement, so they won't interfere with each other.
But they don't care.
No. You can put as many on the shunt as you want.
And what's your time frame to have this done?
The next prototype in 3 to 4 weeks. Then to a product, we will see if we have any problems or not. We will test it first.
We're shooting for in the store by the fall of 2017.
Or later. Well, on that side, yeah.
Now, Paulo, if you'll put a industrial protocol in it, those little bitty fake displays I've got in my car, not necessarily all around it, but there's a lot of them out there that are very low cost, $100, $200 for a color touchscreen. But it needs to be my bus or my bus TCP or some sort of thing. Almost all of them can read that.
Okay.
It's very small protocol too.
Yeah, Modbus is easy to do.
I noticed you have 2 digital outputs in your pulse field logic. Could you use those to drive gauges and cars?
Yes, that's the idea. That's why they are there. For example, at the fuel gauge
Old-fashioned fuel
indicate
gauges.
fuel state of charge. And in the back there.
Yeah, question for you. I remember the first slide you were showing how with the lithium iron phosphate cells, the discharge is very gradual until reaching close to the end of the discharge. And that goes back to the question we had earlier about precision versus accuracy. And the question is, in order to accurately measure the drop during the slow voltage decrease portion of the discharge, have you considered how accurate your voltage measurement needs to be?
We don't need to measure it. We are determining state of charge count with a Coulomb counter, counting how many amps go in, how many amps go out. On the lead acid batteries, you would do that measuring the voltage, but on the lithium you don't.
Right, I see. So your strategy is to use the
Coulomb counter, yep.
Do you have a website?
Not yet. Work in progress.
Yeah. We have a website, but the only thing there's is the
Logo. Well, no more questions?
Are you going to make one for the temperature as well, like the 505? Are you going to make a temperature one?
The temperature
Isn't there a JLD 505 for the temperature?
We could put in a temperature sensor, but
You can add features until you're up to what Ed's doing. This is supposed to be low cost, $150, something like that, a meter.
And there's also
but with very flexible interfaces. Kind of an advance over the 404. Ed and I, and actually Paulo's involved with the next session.